following is a segment from our webinar, HVAC Right Sizing Part 3, Air Distribution and Duct Design, presented by Arlen Burdick and Anthony Grizzolia of IBACOS. More segments can be found on our website or our YouTube channel, IBACOS and the Alliance. This segment features the big picture, why you should care about right-sizing HVAC, and integrated design as it relates to air distribution and duct design.
Getting into the big picture, technical difficulties. What are the impacts? Why is it important to get it right? HVAC design and specifically right-sizing your HVAC system will impact your first construction cost and your operating costs. It's important to deliver that comfort to the room. Get the energy efficiency that you're looking for out of your designs. And for the contractors and the builders, looking for that higher customer satisfaction and less callbacks, less warranty work. There we go. What do we expect our HVAC systems to do? We want the HVAC system to keep the occupants comfortable first and foremost. We want it to operate unnoticed, and that's really where this third section of the air distribution into the house comes in, is in that operating unnoticed. And always energy efficiency is on our mind. Why is right sizing so important? Rules of thumb have always been in play for HVAC design. Our enclosures are improving, better air sealing, better wall construction, better windows. The rules of thumb have not kept up with better enclosures. An older approach would have been a ton per 400 to 500 square feet, and better than code or newer codes that are more stringent, you're seeing that number be much less, a half a ton of cooling for 400 square feet. And even on super high performance homes, getting up in the 1,500 to 2,000 square feet per ton of cooling. This is a theme that's come up in all three presentations that we've done, that it's really not a step-by-step, 1, 2, 3, do this, do that. There's a lot of back and forth within the design. 1 and 2, 1 was load calculations. Load calculations depend entirely upon the house construction and where the house is, and are very sensitive to moving around those parameters, and you really have to be faithful to the procedure and your construction. But once you get into selecting the system and sizing the system and then designing the distribution portion of it, there's a lot of back and forth between the capabilities of the equipment you've selected and how that air is delivered to the room. These are the ACA, Air Conditioning Contractors of America, procedures that guide residential design. Manual J is the load. We talked about that first. Manual S is system selection and sizing. Today we're going to focus on Manual T's and D. Manual T is not so much a procedure, more of theory behind it, and Manual D is very much a procedure. There we go. Challenges and opportunities around these houses that have lower loads. A lower heating or cooling load means there's going to be less CFM required to meet that load. Our traditional way of delivering that air to the room may not deliver the comfort we're looking for. The opportunity of these lower loads and lower CFM delivered is we can have smaller, more compact duct systems, less diffusers in the room or outlets in the room, and still get the efficiency that we're looking for. Duct design and air distribution is really where the rubber meets the road in the HVAC design. The analogy we like to use, we like to go back to car analogies always, but would you really buy 4 tires for $100 and put it on a Ferrari? If you've gone to all this work of building an efficient house with a good enclosure, are you going to skimp on the HVAC? Are you going to get the performance that you want out of the system if you skimp on it? I would say no. Integrated design. Now this is very early in the procedures, long before you've put nail to wood or anything. If you can give consideration to the HVAC placement early in the procedure, early like in the schematic phase of your designing your house, you can make accommodations in the framing. You can create a space for that HVAC system to be located and get the performance from the system you need. Making space for chases, bringing equipment into conditioned space. We've discussed in previous ones how that improves the performance of the system, giving consideration to the noise that equipment's going to make and placing it in the house so you avoid any issues with that. And it's much easier to address these concerns up front when you're laying the house out instead of later after it's been designed and try to fit the HVAC system into what already exists.
Arn, a quick question. When you've worked with builders on some of this integrated design, who's on the team from the builder side to get this right?
You're looking for that integrated, synergized relationship between designers, architects and engineers, and mechanical contractors who are going to be involved in it. And you really can't forget your sales folks, because in the end you're going to end up taking up floor space. They're going to have to be able to sell it, explain it, work around it, and you'll need their input and their buy-in on that.
Arn, just part two.
Yeah.
How much floor space am I going to lose?
If you're talking about bringing equipment inside, the size of a small coat closet, perhaps.
Okay. Good to know.
We're getting into some of the things you're looking for as you do this integrated design. By locating equipment centrally on the plan, you'll end up with shorter duct runs. We're looking to run ducts to interior walls and keeping ductwork inside the thermal boundaries of the house. We'll touch on these points much more later in the presentation. Allowing for adequate space for the ductwork and bringing that ductwork closer to inside the house will help you avoid situations like this here. We're going to discuss why this is bad later, but basically you've got 1, 2, 3 90-degree bends to get from the run to the outlet that's at the exterior side of the wall, because they had to get around that floor framing there. This is the kind of thing that you really want to avoid in your design. This is a, every time I look at this picture I don't like it, and now I know why. It dawned on me. We're talking about having short duct runs. In the perspective you have here, it looks like the duct is right up to the edge of the floor joist, but in perspective, if that's a 10-inch floor joist, that's not a very long duct run. So we're talking about making space within the floor system to run your ductwork in there. By doing this kind of thought and design early, you can get your joist manufacturer's input on what the impact of putting holes through their floor joists are. It's addressing all those hot spots up front early on in the design process.
Arn, if you do this right, will I be able to get rid of some of those bulkheads that traditionally we see in homes, like in basements or on first floors?
That is a big goal of doing this integrated design up front, is to have less of an impact on the living space inside the house. Drop ceilings, bulkheads.
So we may lose a small closet, but our ceilings may look a lot better.
Yes, they may.